Good morning, Algebra Tube students. I hope you had a really good Easter break. Welcome back to distance learning. Today we're going to go back over Chapter 6. Now, I did say on the instructions that this does count as your assignment number 88. Doing this and actually filling in the feedback is super important. I need to know what it is that you still need to ask questions on. As you know, we have a Zoom meeting scheduled a little bit later, so please make sure that if you have questions that you plan to attend that, and also please make sure that when you fill out that review, you explain what it is that we need to still go over, and I can make a follow-up to this for those that maybe can't attend the Zoom meeting or something happens. So I just need to have your feedback on that. So I just want to get us started here and pray for you a little bit. Heavenly Father, please help everybody to understand everything, help them with their needs, bless their families. In Jesus' name, amen. All right, let's move on with this Chapter 6 test review. So, go back over this as many times as you need. As I said, this does count as the assignment, and you're going to be doing your test preparation based on this, and then you'll take your test on Wednesday. Okay? All right, so square roots. Most of you for a long time have been able to do the square roots. Just don't forget that when it says to find all the roots, you're looking for the positive and the negative. So it's not only 5, but it's also -5 here. Not just 1, but -1, because both of those multiplied together give you 1. Not just 9, but -9. And then this, of course, would be 4. 4 times 4 is 16, but also -4. And just to review that the plus minus does mean that it's both of those, plus or minus. Then we moved on to a little bit more difficult, where you needed to find not only square roots, but you may have different indices to be able to find these things. If it's an easy to find square root, you would just keep that number, and then don't forget that you take the exponent divided by the index. Hidden index here is 2. So, of course, what that would mean, square root of 64 is 8. There are 4 groups of x's here, so x to the 4th. Exponent divided by index. Exponent divided by index. 20 divided by 2 would give you 10, and of course square root of 9 is 3. We don't need a plus or minus here. Only time you need that is if it says to find all of the real roots, but simplifying the radical expressions doesn't imply that, so you don't need the plus or minus. Do watch out for negatives, especially when you have odd roots, because when you have an odd root, just like when you have an odd power, you have a negative to an odd power or a negative with an odd root, that means your answer is going to be negative. So you're looking for a negative something, and that something has to be multiplied together 3 times to give you 0.008. So you might initially think of it as being something like 0.002, but when you start to multiply those out, you'd see a whole bunch of zeros coming out for you. So just -0.2 is what ends up giving you that answer. 0.064, you might need to think about numbers a little bit. You might try 2, but 2 times 2 times 2 is 8. If you try 4, you get 64. But then just watch out for the decimal place for your final answer, because it has to be where 0.4 times itself, and 0.4 times itself. Does give you 0.064. So you could always go back and check it just to make sure you're right and to do a good job with that. All right, now when you're trying to find the real solutions for a problem where you need to use a square root to solve, there are the 2 real solutions that you're looking for, so please be careful with that. So in doing these problems, because even though it's a quadratic, yes, you could use quadratic formula, you could use the factoring method, but on something like this where you just have a square and you just have one other piece, it's usually easier to just move this over by adding 9 to both sides, or move this over by adding 16 to both sides, and then finish off solving it by isolating the x squared, and then square rooting both sides to get rid of the square, keeping in mind that you have a plus or minus situation, but when you have a fraction, you can take the square root of the numerator, square root of the denominator, so ending up with 3/5 there. Same with this one. You bring over, divide by 36 on both sides, then square root, but it's plus or minus. Square root of 16 is 4, and square root of 36 is 6. But don't forget, you're always needing to reduce to lowest terms in any case. So 4/6 does reduce, both divisible by 2. Okay. Now I'm going over the things that seem to be a little bit easier, a little bit quicker, but remember, you can always slow me down, and you can always go back and look if it's something that you had more difficulty with. All right, now when you have the same index, don't forget that you are allowed to bring it underneath of that radical together. So since these are both square roots, you can bring them under the radical together before you simplify. That helps you out a lot, because if you were to use factoring method here, you'd have an extra 2. But if you start off by just bringing them under the same radical, it makes a problem like this much easier, because the square root of 64 is 8. And the square root of x to the 6th is x to the 3rd. Now, some of you might say, but wait, remember you said when you take a square root and you have end up with an odd power that there would be absolute value. Well, yes, except for the fact that in our original problem, when we take a look at that, we have the x would have to be positive in the first place, or this wouldn't work. We'd have an imaginary. So because we have odd powers underneath, that rule doesn't necessarily always apply. But if you put the absolute values here, it wouldn't be wrong, but you're probably safer just not, because sometimes you could run into a situation where it was wrong. So 8x to the 3rd here. Square root of this, when we put it together, 16 of course is 4, and then x to the 4th power, and absolutely no need for even considering an absolute value when you have an even power. And if you forgot about the absolute value, as I said, it's not really a critical key point in our thing, but I just know some of you think of all of the things, which is great. All right, let's move on. All right, this problem right here, it looks as if you can't put it together because you can only add or subtract things that have the same radical, but on this case we can simplify them, so we need to remember how to simplify your radicals before you start to put them together. So as we go through here and we begin to simplify, remember you can factor out the 20. It's not something that's an exact square root, so you have to factor out. You're looking for pairs. So there's a pair of 2's here, changes it to 2 square root 5. If you need a longer explanation, please go back and watch the appropriate video for these. All right, so square root 45, we factor that out. We have a pair of 3's, so a 3 comes out. The 5's left by itself. And square root of 80, when we factor that out, we have a pair of 2's and another pair of 2's. That would be 2 times 2, which would give you 4 square root of 5. Then they're all square root of 5, so after you simplify this 8 times 4, you can put them together. 2 minus 3, negative 1, plus 32 would be 31 square root 5. And be done with that. Okay, this is from the beginning, the first half of the chapter. That might have been something that you go, oh wow, now I remember that we did all that. So let's move on. We also had things where you had to rationalize the denominator, and in rationalizing the denominator you had to consider the conjugate of the denominators in order to solve this. So remember, conjugates are you just take this minus and turn it into a plus. If you have a plus, you turn it into a minus. And whatever you do to the numerator, you have to do to the denominator. And if you'll remember, our whole purpose in this is because when you would multiply this out, 5 times 5 is 25. This one and this one would be equal and opposite, so they'd cancel out, and we'd end up with a minus 2. So rationalizing the denominator, meaning that we no longer have any radicals, no more square roots, no more cube roots or anything like that. So conjugates are helpful for that. The numerator, we have to go 3 times 5, 15. 3 times square root of 2, 3 square root of 2. 5 times square root of 2, 5 square root of 2. Square root of 2 times square root of 2 is 2. And then putting our like terms together and simplifying, 17 and 8, and then 23 in the denominator. Nothing else to do with that because no common factors. Even splitting it up, you're not going to find anything to cancel that out. Now we said conjugate for this one too. There's our conjugate. You're really only multiplying by 1, so you have to treat numerator and denominator equally. 2 times 2 is 4, minus 3. These middles canceled out when you multiply negative and positive of the same thing. 8 times 2, 16. Minus 8 square root of 3, plus 2 square root of 3, minus 3. Then like terms going together, and it's all over 1, so that's convenient. 16 minus 3, 13. Negative 6 square root of 3 over 1, so it just simplifies very nicely like that. So you're going to make sure that you're practicing. You do have problems that you can do in the back of the book from the original assignment 88, but you're doing the ones that you feel like you need to go back over for extra practice, and you bring your Zoom meeting questions, or can you go back over whatever concept you need when you give your feedback. Okay, here we go. We've got radicals that are already simplified or already isolated, but in order to solve them, remember, you have to figure out what power to raise these to. Whenever you have a root, you can use the same exponent. So since this is a square root, we take it to the second power. When you have a fractional exponent or a rational exponent, you take it to the reciprocal power. And let's take a look at those two things. So I want to square both sides. When you square both sides, we get the radical disappears, and then it becomes the very easy algebra that you've been doing for years, bringing that down like that. Back with this one, the reciprocal power would be to the 4/3 power. Remember, we do power to a power so that they will cancel out in effect, because 4/3 times 3/4 turns into a 1, and then that eliminates that. X to the 5th, x minus 5 to the first power is just x minus 5. This one, remember, this is the power, this is the root. So the cube root of 27, which would be 3, to the 4th power, gives you 81. And then once again, that nice simple algebra that you've been doing forever. Decimal exponents are better thought of as fraction exponents, especially if they're these nice simple ones. 0.25 is a quarter. 0.5 is a half. Okay, think money if that's tricky. So 625 to the 1/4 power. Remember, this is our root. We're taking the 4th root. So you're looking for what number times itself, times itself, times itself. So you've got 4 of them, would give you 625. And that number actually is 5. Look for the small simple numbers and check those out first. and you'll find it pretty quickly. 25 to the 1/2 power, of course, square root 25 is 5 also. Okay, so you're going to be looking for whatever those powers are. Okay, now these become a little trickier because you've got a binomial to square on the other side, because you do still have to square both sides to get rid of this square root. So when you do that, be careful in your multiplying. X plus 5 times x plus 5, remember, is x squared plus 10x plus 25. If you need to take a minute and do that out, by multiplying and distributing, or FOIL if you think of it in that way. And then it's a quadratic, but it's not as simple. So we need to get a 0 on one side, so we need to take away the x from both sides and take away the 11 from both sides, so that you get a 0, which makes it a very nice quadratic. A nice factorable quadratic for that matter, because 14, the factors of 14 that add up to be 9 are 2 and 7. You just have a 1 for your number right here, for your coefficient. So you can go straight into making it x plus 2 times x plus 7, which means that you have two possible answers. You have x equals -2 or x equals -7, which when we check them, the -2, when you plug it back into the original equation, does give you square root of 9 equals 3. Now we are looking at the principal square root here, not both of them. This one gives you a -2, so not really quite what we're looking for. That one's extraneous. All right, because the -2 definitely gives you one that works, and this one not so much. This part on your quiz, now I'm going to take a little more time on some of these because this is a little bit harder. This part on your quiz actually was pretty good. You guys did great. You knew that adding meant you just put them together by adding. Okay, so f plus g of x means you take the two expressions and you add them. So we ended up with 2x plus 4. And subtracting, you did great, most of you. So x minus 3 minus the other expression. The only thing is that don't forget that you need to distribute that negative. I think there were a couple people that needed some help with that. Don't forget to distribute the negative when you're subtracting. But then when you put it together, this one just turns into a -10. The x's disappear entirely. Now f times g, notice this is a small dot that's filled in. That means times. And remember, I had said that there's a difference between that small dot that's filled in and the big dot that's an open circle. If there was a mistake made, it was people thinking the ones that were an open circle was this small dot. The small dot means multiply. And that was pretty good for you guys. So x squared plus 7x minus 3x minus 21. Like terms go together and you get this very nice expression here. Okay? But here's the thing. When we do the open circle, the composite function, make sure that you're really paying attention to that, because that's where the trouble came in. Now the dividing one, once again, it's dividing the first function by the second function. This one there is no simplifying. On your quiz there was some simplifying, and you can go back and look at the quiz review for the simplifying ones, where if you have to simplify first and then cancel, but you also have to look at the domain. Remember, the domain is found by finding anything that doesn't work. Since x plus 7 can't be equal to 0, that means x cannot equal -7. So we have that restriction, so that answers our question about the domain of that function. I know that was a sticking point for some of you, is figuring out the domain. Now we have also composite functions. On the composite functions, this is that circle. It's not the same as the raised dot. This does not mean multiply. Okay, and if there were mistakes made, the mistakes came in thinking that this means multiply. It does not mean multiply. It's a composite function, f of g of this value. That means, once again, you do the function that's closest to the number first, g of 8. So we're going to take g of 8, which means you plug the 8 into the g function. 8 plus 7, 15. Okay, so we've got that part. Then you apply the f function to it, f of 15. So then when you take f of 15, you're plugging 15 into the f function, 15 minus 3. 15 minus 3, which gives you 12. So your final answer is 12 after you have applied both functions, whatever they are, whether they have squares, whether they have whatever, you apply the one that's closest to the number first, and then apply the one that's furthest from the number after you have found that subnumber. Then this one, you're applying the f function first, f of 9, which means you plug in 9 and you get 6, because 9 minus 3 for the f function gives you 6. Then you apply here g of 6, and 6 plus 7, 13. Okay. You can also be asked to do this in general with the x functions. Now, many times it does matter. They're not always commutative, so you do have to be very careful to do these things in the correct order. Okay, sometimes it does become commutative, but not, it's only sometimes, so don't count on it. So f of g of x means that you're finding f of, here's our g of x right here. Okay, so we're trying to find f of x of 7, x plus 7. So that means that you're going to be plugging x plus 7 in for this x. So when we do that, x plus 7 goes in for this x, and then we have this leftover minus 3. And you put them together and get x plus 4. So f of g of x is x plus 4. Okay, g of f of x. As I said, it's not always that they'll end up being commutative. We have to be very careful with this. We want to find g of x plus 3. Sorry, g of x minus 3, because x minus 3 is what f of x equals. F of x is x minus 3, so we're finding g of x minus 3. So that means we need to put x minus 3 in where this x is. So we plug that in, x minus 3 plus 7. In this case, we get the same answer, but you're not guaranteed. You always have to make sure that you are doing things in the right order, because it could possibly come out to be the same answer, but it might not be the same answer. The other examples that we did before, they didn't come out to be the same answer. So you have to be super careful what you're doing. You do the one that's closest first. Maybe that'll help some of you to understand that didn't understand. I tried to make my wording slightly different because it didn't stick for some of you the first time. Okay? So you're always doing the one that's closest first, putting that in. Okay? All right, then we get to inverses. Now inverses, this is your y, this is your x. So we start off by writing it in terms of y and x. Then in order to do the inverse, switch the x and y. Okay, some of you in your quiz did not switch the x and y. Some of you left it and then solved for x. But what we need to do is switch the x and y, then solve for y, which you end up, once you have y alone, this 6 applies to both. This one can be reduced. That's great. This is your inverse function. Okay, yes, you did lose a little bit if you left this one as y and this one as x because you didn't switch them. Our inverse function looks like this. This is the inverse notation. F inverse of x equals 1/6 x minus 9/2. So be careful of that. And then this one, the shortcut, f of f inverse of 92 is just 92. F inverse of f of 87 is 87. I think everybody got that one right. So just to remind you of that. Now we had one last section that we did, but we didn't get a chance to put it on a quiz. I don't have much in there on this section, just a little bit, but you need to make sure that you're including this in your study notes. These are all shifted functions of the parent function y equals square root of x. Okay, so really all you're doing is figuring out what happened to the graph, which way did it move off of 0, and then applying that to the square root function. So this one is a square root of x, but it moved to the right one, and moving it to the right one, remember it's x minus h and then a plus k on the outside, x minus 1. I'm not even doing stretches or compressions on this test. But this moves to the right one. This one moves up 2. So square root of x plus 2. This one moves left and down. Left 4, down 1. Left gives it an x plus 4, and down gives it a minus 1. This one is right 2, down 1. So right 2, down 1 gives you minus 2, minus 1. All right, and that's a really good way for you to study, is going back over and over the things that you need to make sure that you're understanding. I did notice when I looked at the video analysis on YouTube that some of you are going. It shows me that sometimes people go back over stuff. Good job if you're doing that. Go back over things, make sure you're understanding, make sure that you're prepared. Don't forget that Zoom meeting if you need to ask some specific questions, and we can work on it on a screen share. And then also make sure that you're telling me, giving me feedback so that I can give you more feedback tomorrow with whatever's needed. All right. Glad we had a chance to have this all come together, and we've got a plan working ourselves all the way up until May 15th, but then I also have my bigger plan for the rest of the year, and we're going to get you guys where you need to be. Thank you for all your hard work that you're doing for yourself so that you can understand. God bless you and have a great day.